Our Milky Way galaxy in profile looks like a UFO or a pancake. We identify three major areas: the galactic disk, the central region, and a halo all around the Milky Way with a globular star cluster. As seen from above, the Milky Way is a spiral galaxy with a bar of material cutting through its center. Age of the Milky Way galaxy, 13.5 billion years. Yes, it is a barred spiral galaxy, and the current star count, 400 billion stars. Yet, 90% of the mass has not been identified. These mass are no star, no gas, no dust. It doesn't emit any detectable radiation. So what is? It is dark matter. On the galactic disk, packed with gas and dust, you have a young star. Hot and young, you know the type, O and B. So the color of the galactic plane or disk is a nice blue and white. The bulge or central region is home of our supermassive black hole with a mass of 4.3 million times our sun. In the central region, packed with stars melting into each other, these stars have a random orbit. They plunge through the disk in any possible orientation. The halo is a leftover so old, contains more than 200 globular star clusters. But the halo has no dust and no star. What does it mean? That in the halo, no new stars can be formed. The galactic disk has a gas cloud, dust, young stars, horn B. Our sun is in the galactic disk in one of the spiral arms, a little bit below the galactic disk. That's why when we look up, we have this magnificent view of the Milky Way, like a river of stars from one horizon to the other. The sun orbits the black hole at 220 kilometers per second, which is the equivalent of 500,000 kilometers per hour. It takes 220 million years to revolve around the black hole. Now think about, since the Jurassic era was 65 million years ago, it means that we only went around the black hole for a third of its orbit, and humankind have been alive even for less time. Truly spectacular. So how do we know that on the galactic disk we have all this hydrogen gas cloud? Well, it's very simple, because hydrogen sing a song at 1420 megahertz, which correspond a wavelength of 21 centimeter. Yes, it is very much similar to when you listen to the FM radio. You tune to the frequency of your favorite radio station. In astronomy, we do the same. Radio telescope, big dish antenna, tuned at 1420 megahertz. And this is where we can find those hydrogen clouds that are sight. They are nursery of young stars. So what's happened? What hydrogen is doing? Why hydrogen is singing? Very simple. I'm gonna take two hydrogen atoms, the proton at the center, This is spinning counterclockwise in the nucleus. The electron also negative, spin counterclockwise. But when a radiation from a star is being absorbed by the hydrogen atom. Look what's happened to the electron. The electron flip the spin upside down, and this electron start to spin clockwise. In this state, the hydrogen atom is in an excited state. It cannot stay for long in an excited state and has to return back the energy that has absorbed. It's almost like a karma law, right? A karma, like what you take in, you have to return it. Hydrogen atom is now returning back this energy as radiation at 1420 megahertz, which correspond to a wavelength of 21 centimeter. The halo is actually almost invisible. It surrounds completely the Milky Way galaxy like a bubble. In the halo you find this object, globular star cluster, 200 of them. Again, no gas, no dust, so no new stars are being formed for the past 10 billion years. So these objects are very old. Look at that. Let me zoom into. You can see clearly that you can have millions, if not trillions of stars all packed together in a very small area. A radius of maybe 40 light years across. Star highly concentrated toward the center, moving toward the center under gravity. They melt into each other. This is the halo of the Milky Way galaxy. The central region of the Milky Way galaxy, you are seeing our supermassive black hole observed in radio waves. It is simply called the Sag A because it is in Sagittarius. Here it is, perfectly round, 1 astronomical unit in diameter, very well observed in radio waves, with synchrotron emission being so very strong. If you are thinking that you can see the black hole with your eye in visible light, the answer is no, because the most important area of the Milky Way, the core, the galactic core, is hidden by very thick dust cloud which blocks the view. But look at this black hole. Look at this filament coming up, moving upward, perpendicular to the galactic plane. Then they even bend and fall back down on the galactic plane because of gravity.
NASA has captured a new infrared image of the center of our Milky Way galaxy, revealing details that have never been seen before. Scientists have tried for many years to peer through the dense swirls of dust obscuring many of the Milky Way's fascinating features. SOFIA, NASA's telescope on an airplane, observed our galaxy's center in infrared light, which is invisible to human eyes but pierces through the dense dust. Now we can see new details in the curves surrounding the Arches cluster, the densest concentration of stars in our galaxy. Also visible is the quintuple cluster, with stars that are 1 million times brighter than our Sun. Our galaxy's supermassive black hole takes shape with a view of the fiery-looking ring of gas surrounding it. NASA created the panorama by combining SOFIA's new, crisp image with previous data from the Herschel and Spitzer space telescopes. Scientists will use the image to study previously hidden facets of our Milky Way galaxy, including how many massive stars are forming here, and to set targets for telescopes of the future like the James Webb Space Telescope.
In our supermassive black hole, proton and electron collide and they annihilate. light, creating gamma ray emission. If Earth, our planet, was in the galactic center, our night sky will glow like 100 full moon. X-ray is produced by gas falling into the black hole at 4% the speed of light. Yes, around the black hole, stars melt into each other. They become gas. This is a very active area. Look at this photo. Look how the gas is already spiraling onto the black hole. The galactic center and inside of the black hole, the Milky Way, is very active. I wish we could have X-ray eyes and see what's happening. But wait a second, we do have X-ray satellite in orbit, so we can see what happened in other galaxies. I found these videos from NASA Hercules A. This will be the Milky Way invisible light, and with X-ray eyes, take a look, you will see filaments of gas 65 light years long, radio emission with bipolar lobes of hot ionized gas emitting X-ray. These bipolar lobes extend 12 light years away. This is how our galactic center would look like.
In 2011, NASA's SWIFT satellite caught an X-ray outburst from a small galaxy 3.8 billion light-years away. Within a couple of days, researchers realized they were witnessing the aftermath of a tidal disruption event, a star ripped apart by the monster black hole at the galaxy's center. Some of the stellar material fell toward the black hole, forming an accretion disk and a jet pointed in our direction.
Tidal disruption events offer us this rare view at the most common kind of supermassive black hole in the universe, these so-called dormant supermassive black holes. 90% of black holes in the universe don't have a lot of hot material orbiting around them. They don't form these accretion disks, and so we can't observe them. Tidal disruption events, where the stellar debris causes the formation of a temporary accretion disk, offers us a way to probe this population of supermassive black holes.
SWIFT monitored the outburst's progress and was joined by the European Space Agency's XMM Newton Observatory and the Japanese Suzaku satellite. Recently, astronomers introduced a new analysis technique that for the first time allows them to peer deep into the gravitational well of a normally quiescent black hole. Called X-ray reverberation mapping, the method charts the region close to the black hole using light echoes from X-ray flashes, similar to the way sonar uses sound to map the ocean floor.
X-ray reverberation mapping has been very successful at probing the accretion flow in well-established accretion disk structures, but had never been used to look at tidal disruption events. My collaborator at the University of Maryland and I were having lunch one day, and she says, "Has anyone ever looked at tidal disruption events with X-ray reverberation mapping?" That night, I stayed late at the office and just tried it out on this data from Swift J1644, and much to my surprise, the result was amazing, and I could see that we were looking at the structure of the inner accretion flow around a normally dormant black hole for the first time. It's not like a normal accretion flow in an active galaxy that's a flat disk. This is something that is extremely puffy, very turbulent, and we are measuring flashes of X-ray emission deep within this newly formed accretion disk.
Stellar material streamed into the developing disk, churning it into a thick, chaotic whirlpool of X-ray emitting gas, funneling toward the central black hole. Deep inside this cavity, multiple X-ray flares erupted, providing a flash that echoed throughout the region.
Previously, astronomers had thought that the X-ray emission is coming from far out in a jet. But what we're finding with these observations is that the X-ray emission is coming from flares very close to the supermassive black hole. And we can use these observations to probe properties of the black hole itself. For instance, we found that the mass of the black hole is something on the order of 1,000,000 times the mass of the Sun.
The first observations of X-ray reverberations from deep inside an accretion disk are providing new insights into a rarely observed class of black holes. They're also laying the groundwork for a better understanding of tidal disruption events and the black holes they illuminate.
Question for you: why do orbits of bulge star bob up and down? Because they are stuck in interstellar medium, because of the gravity of the disk, or because the halo knocks them back onto the disk? Answer is B, the gravity of our galactic plane. Second question. Now consider the vast distance between the stars, right? So it is likely that the two stars will collide. Well, what would you pick? No, the stars are very small compared to the distance in between. No, they will not collide because stars are not moving in the galaxy. Yes, it is likely to occur the star will collide. Yeah, which one? Answer is they are very unlikely to collide because the distance in between stars are very, very wide. So you know that the Milky Way, being smaller, is being pulled into the Andromeda Galaxy. Yes, they are on a collision course. But nothing to worry about. We still have a couple of billion years to go. But in the meantime, take a look.
Andromeda versus the Milky Way. Astronomers predict a titanic collision. Presented by Science at NASA. Imagine having a galaxy fall on your head, and you survive the experience. NASA astronomers say that's exactly what's going to happen to our Milky Way galaxy approximately 4 billion years from now. New data from the Hubble Space Telescope confirm that the Milky Way is on a collision course with the great Andromeda Galaxy. When the mashup occurs, say researchers, it's likely the Sun will be flung into a new region of our galaxy. But Earth and the solar system are in no danger of being destroyed. After nearly a century of speculation about the future destiny of Andromeda and our Milky Way, we at last have a clear picture of how events will unfold over the coming billions of years, says Sangmo Tony Son of the Space Telescope Science Institute in Baltimore, Maryland. Astronomers have long known that Andromeda and the Milky Way were converging, drawn together by their mutual pull of gravity and an invisible dark matter halo that surrounds them both. But no one knew whether the far future encounter would be a near miss, a glancing blow, or a head-on smash-up? It all depends on the amount of Andromeda's sideways motion. A lot of sideways motion would allow Andromeda to sail wide of the Milky Way, missing our galaxy entirely. Less of it would bring the two galaxies directly together. The Hubble team, led by Roland van der Marel of the Space Telescope Science Institute, conducted extraordinarily precise observations of the sideways motion that removes any doubt. Andromeda is destined to collide directly and merge with the Milky Way. Although the two galaxies will plow into each other, stars inside each galaxy are so far apart that they will not collide individually. Instead, the stars will be thrown into different orbits around a new combined galactic center. Simulations show that our own sun will probably be tossed much farther from the galactic core than it is today. Team member Gertina Basla of Columbia University in New York describes what a head-on collision will be like. The stellar populations of both galaxies would be jostled, and the Milky Way will lose its flattened pancake shape. The two galaxies' cores will merge, and the stars will settle into randomized orbits to create a new, elliptical-shaped galaxy. To make matters more complicated, Andromeda has a companion, the Triangulum Galaxy, also known as M33. M33 is a relatively small galaxy, not nearly as large as Andromeda or the Milky Way. Nevertheless, it could play a big role. M33 will join in the collision and perhaps later merge with the Andromeda-Milky Way pair. There's even a small chance that M33 might hit the Milky Way first. Amazingly, Earth and the solar system should emerge from the melee unscathed. We'll just have a new galactic address, and perhaps a night sky with a double helping of stars. It turns out that a galaxy falling on your head isn't so bad after all. For more news about cosmic collisions and the future of the Milky Way, visit science.nasa.gov.
Welcome to Hubble. Classification of galaxy is a tuning fork, yes, like the one you use to tune a musical instrument. I love music, you know. Take a look. This is not a classification of evolution. It's just a way to recognize this beautiful galaxy. On this horizontal branch, you have spherical elliptical galaxy. Up here you have a spiral, and down here you have a spiral galaxy with a bar of material in its center. Why is it important, this classification? Because the area of the central region, how big it is, determine the winding of the spiral arm. What does it mean in simple word? I show you. The bigger is the central area, the more tight wound up is the galaxy. So imagine a big central area, a lot of gravity, so the spiral arm are really close to. When the central region is very tiny, this spiral arm, you see them departing almost vertically, like in this photo. You see how they go out almost straight. So same concept apply also to the barred spiral galaxy, which has a central region and a bar of material. You can see this arm very loosely wound up. A great way to classify galaxy, very much spiral galaxy. I'm going to go through very quickly. A spiral galaxy seen edge on. You can see the disk, the galactic disk. Look how much dust. And that's the bright central region. Another spiral galaxy with a bar of material. You can see there are dust cloud, stars, and the central region. In a barred spiral galaxy, the spiral arm depart from the end of the bar. Other type of galaxy are a lenticular with a disk similar to a spiral galaxy, but very little dust. Elliptical galaxy, I like to call them, they are a football shape, really no major structure, random distribution of stars, not a clear spiral arm. on elliptical galaxy, and the irregular. Oh, this is a variety. These are artistic galaxy, every form or shape. But why they are important? Because the Milky Way has two satellite galaxies. They're called, remember, the Large Magellanic Cloud and the Small Magellanic Cloud, two beautiful irregular galaxies spinning around. Oh, by the way, there is also a third one, a satellite of the Milky Way. Wow, we are important. Yes, the third one is called Dwarf Sagittarius because it's right there hanging outside the central region on the way on a collision course with our black hole. Dwarf Sagittarius is a petite, is a small galaxy satellite, so it will be cannibalized. It will be eaten up by our black hole, this irregular galaxy.